in 10.1.34 and Apache 9 fixed later in 9.098. Okay, cool. So, right, read, compile, put, get, and the CVE 22450. I'll just be saying the last. So 50379 is an example of a time of check, time of use. Um, Talk to, I believe is the acronym for that one. Vulnerability. A talk to vulnerability arises from a race condition between checking a resource and using it. In other words, after a system checks the state of a resource and before using it, the resource changes and the system ends using the changed resource. This In this vulnerability, the talk to race condition arises during the JSP Java servlet page compilation on case-insensitive systems, provided the default servlet has write permissions. Just going to allow that. All right, so learning objectives in this room will cover the following. What's a talk to and how it can be exploited, exploiting a vulnerable version of Tomcat, detecting such an exploitation, securing your installation. What is the acronym that stands for time of check, time of use? So that's going to be this one right here. I'm just going to paste that in there. All right, cool. All right, I'm just going to move this over to the right a little bit more so you can see it, and go ahead and press enter. And we'll move on to the next one here. So task 2 is the technical background. So let's see here, it's a lot of reading. I'm going to start the machine so we have that ready to go. And look at this here. So you might be asked how talk to applies in this case. Before elaborating on this, we should mention that there are two main conditions for vulnerabilities to be exploited on a vulnerable server. First and foremost, the server allows users to upload and delete files. The server is configured to accept HTTP commands such as put and delete. Writing is enabled by setting read only to false in the web.xml configuration file. Note that the default configuration is read only. All right, so those are the conditions. And below is an example of an insecure configuration in which the application server is set to allow writing by default. Okay, so let's see here, by default, read only is false. That means it allows writing. Second condition for this exploiting this vulnerability is for the Tomcat to run on a case-insensitive system such as MS Windows or Mac OS. When these two conditions are satisfied, all right, case-insensitive system. Okay, exploiting this vulnerability is a matter of racing with the OS. Only case-sensitive systems like Linux, demo.jsp, and demo.jsp are two different files. Consequently, on Linux systems, it is not impossible to see documents on documents coexisting in the same directory. Because the MS Windows system is case insensitive, demo.jsp and demo.jsp can't be two different files. However, for Tomcat, the former is a servlet that can be executed, while the latter is treated as a text file. In other words, MS Windows would treat demo.jsp no different than it would treat a servlet properly named demo.jsp. It is Tomcat's in case insensitivity checking that will stop demo.jsp from getting executed and prevent treating it as an executable file. All right. Click the Start Attack Box button at the top of the page and wait for it to load. Furthermore, click the Start Machine button below to get your target system up and ready. All right, please allow 5 minutes for the target system to properly boot. Once both systems are ready, open the terminal on the attack box to follow along. All right, let me go ahead and include the blank machine. All right, there's the machine. I'm just going to go ahead and open up a terminal real quick. And it's got all our RPs here. So this is good. All right. First thing we're going to do here is if we try to create the file demo.jsp, for example, using curl x put d test, and then we're curling this to, I guess, the web server. Put that on the web server via put command will produce an error. This error is expected as servlets can execute commands on the server side, therefore allowing users to upload .jsp files gives them remote code execution ability. In the terminal below, we see an example error. Okay, not found. Let's create a file with the extension JSP or JSP. This step should work successfully as Tomcat does not see such extensions as executable. Right, we can see that demo.jsp file was successfully created on the server. All right, so we'll do this one instead. And let me just verify that is the correct IP address. So it's ending in 7656. Scroll up 7656. Okay, that's the Tomcat server. Gonna paste that in here and send it. If we try to access demo.jsp, a case insensitive system, we'll see it no difference than demo.jsp, but Tomcat's case insensitive will inspect the extension and treat it as a text file instead. It is shown that when the server is under heavy load, a race condition becomes possible. The demo.jsp might get compiled and executed as a servlet because it is a case-insensitive system, enforcing the constraint on the servlet extension such as JSP or JSP has shifted from the OS to the application server. In other words, when a system is under load and there is a current read and write of the same file, the case insensitivity checks might get bypassed, resulting in the file upload getting executed as a serverlet. Okay. A Tomcat server is listening on that port. What is its version? Let's see if they provide us the version. I think for that one, we can probably just do a curl request and see what version it is. So curl, instead of setting the file, we'll just curl the information here. Move some of these here. All right, see if it provides anything here regarding version. You can see this is Tomcat 10.1, I believe is what it's saying it is. So if I had to look at the version of what's vulnerable, we got 10.1.0. So it's probably this one right here. If that's correct. Too short, huh? No. Okay. All right, let's just go. Oh, here it is. 10.1.025. Yeah. All right, cool. So we came across several proof of concept exploits. One being this, you can download it to the attack box using the following commands. We're going to git clone that repository. Go ahead and look down here, drop in the command. Go ahead and get that. All right, cool. We will make two changes to the script. Modify the loop counter in the slab environment using an attack box, a target VM. We noticed that repeating each of the four requests 2,000 times instead of 1,000 was more efficient. Changing the payload for a more interesting exploitation, we will use a reverse shell instead of starting the calculator on the target system. We recommend using the attack box over the local attack system connected over VPN as the attack box ensures minimal latency. For your convenience, the updated Python script can be found on the attack box here. Okay. Right, so we can just go here instead. Well, we already downloaded it, so I don't recommend the updated Python script. Okay, so I think what they mean by updated is that it's already ready to go. Like they've already updated it. So let's cd into that directory and see if what it looks like. 50379. And go to ls. And you can see that they've got the POC file. So I'm gonna go ahead and cat it out. That way I can see what that looks like. And we'll see if they've made the proper adjustments, which it looks like they probably have. Yeah, so you can see here for the range. The original POC code repeats the for loop, was that 10,000 times in line 43. For better use experience and efficient results, we recommend lowering the number to 2,000. The updated line is shown below. So they already updated that. Keep in mind that this edit only applies to the attack box. While we recommend using the attack box for this room, please keep in mind that your VM might need a different number. Changing the payload. The proof of concept exploit uses a payload that opens the calc.exe, as can be inferred from line 37. To simplify this exploitation, we have installed netcat on the MS Windows server. Therefore, we will replace the payload with another one that connects to the attacker system. The commented out payload and the new one are shown below. So that's going to connect to our, that's line 37. Let's see, 37, pay put. Here it is. Okay, so I need to open this with nano. So to previous command. I hope they have nano on here. Yes, all right. Because I don't like using Vim. I can't use Vim. I need to learn Vim, but look at my cheat sheet for that. All right, cool. So let's see here. All right, here we go. This is what we need to edit. Putting our connection IP here, which should be right, 1027. Is that our IP address? Let me double check. 6. Yeah, okay. So that's ours. So 10.201.17.10. All right. See what else do we need to do. All right. This payload uses JSPs, runtime get time exec to execute this CMD C start netcat and then CMDEXE and the IP address and the port number as mentioned. This is possible because we have installed Netcat for demonstration purposes. Before running this POC, we need to listen for incoming connections. Let's start Netcat on the attack box with netcat-l, v, and p. Okay, so we'll go ahead and save this. I think that's the only changes we're going to make. So Control O, Control X to save it, and then open up another terminal. We'll open terminal, open tab. I like using open tab and then just renaming my tabs. I could set this title to NC. So I know what that tab's doing by right-clicking and then set in title. Helps me be organized. I can just move between them, right? It's a little easier for me that way. Sure, you can use tmux, and I like tmux, but I don't like having to switch between them on tmux. This is my box, so. Next, on the attack box, we will run the exploit with the command, and then we're going to do this here. Base conditions, okay. Run this command will display a message like checking HTTP port number, and the terminal will stop showing updates for a few minutes. During this period, the exploit code sends many requests to overload the target server and successfully produce a race condition. Please wait as the script executes while watching the terminal running the netcat command. Patience is key. Note 2, because this is a race condition exploit, you might need to repeat the POC multiple times before succeeding. When the exploit succeeds, a connection will be established with the listening netcat. The terminal below shows an example. Wow, okay. That's easier than I thought it would be. So next, we're going to go ahead and ls, and I just want to make sure that, okay, so you have the proof of concept, and then you have this base condition CVE file. I wonder if that's the same one as the POC, but I guess we'll see. Because if it doesn't work, then yeah, it probably is. All right, so you can see here it's got the IP address, which we need to double check is ours. 7656. Yes, it is. Okay, so that's the attack box. Or that's the box we're going to attack. It's the victim. All right, so next we'll go ahead and run it. And it's checking, overloading that Tomcat server with requests causing the race condition, which we should receive some type of connection back via remote code execution. And just wait here. What are the contents of the flag.txt file? So we'll just give that a second. Okay, one thing I realized is that the RCA file is it requires us to edit it as well, and that's why it wasn't working. So once we edit, it should work. So this Apache Tomcat RCE file, we'll go ahead and nano that as well. If you're doing this on your box and it's not working, it's probably because you may need a sudo open that file and edit it. But for this one to work, let's go ahead and change the IP address parameter. And once I can get to it. And where are you? Oh, there it is, the payload. Not to change the payload to not open the calculator. Wait a second. Oh, it's already done. So it's already okay. Never mind. You don't need to do that because it's commented it out. So that should be good. And then for the range, let me check the range here. So the range is set to 10,000. Um, that's commented out and set to 2,000. So we should be good there. So Control O, enter Control X to save it, and then go ahead and run that command that we ran earlier. And that should work. Should get connection back. Alrighty, we got the connection. So you can see here we're starting off in the Tomcat file there. Let's go ahead and CD to wherever the flag is. So where's the flag in this scenario? It's in the C location. So C, all right, ls dot, oh, okay, dir. I forgot we're on Windows. Okay, and we have the flag there. So type flag dot text, and that's the flag. If I can copy this, see if it makes me do the clipboard thing. No, it's worked. Heck yes. Okay. All right. So detection, web access logs. Since the vulnerability relies on race conditions, success, and requires file uploads for every exploitation attempt, it is easy to detect in web access logs. Available by default is the C program files, Apache Software Foundation, Tomcat version logs, access logs files. The simplest attack on websites with unrestricted file upload will get logged as the following. Put request to upload the file with uppercase JSP or JSP extension. Put, okay. Get request to the same file immediately after, but now the JSP extension. Get request is logged with either 200 or 404 status codes, depending if the race condition succeeds or not. The steps above are repeated until the race condition is successful. Usually it's 1,000 or more attempts. Suppose the target web server does not allow direct file upload via put, but still has some web upload capabilities like pictures or file upload functionality. In that case, the attacker will have a similar iterative pattern, a request on the web upload form followed by the request on the uploaded malicious JSP file. Okay, so they could also do it via that. Detection system logs. In addition to web-based detection, the attacker can be tracked on the OS and file system level using the default Windows event logs or specialized tools like Sysmon. In short, the detection can be built around file creation. Uploading JSP files remain inside the root directory unless threat actors manually remove them. Any suspicious named JSP files like revshell.jsp or unrecognized JSP files containing strings like .exec can indicate the attack. Process execution. Uploaded JSP files usually have to spawn a child process to achieve code execution. On Windows, seeing Apache Tomcat spawn, CMD, or PowerShell processes might be another reliable attack indicator. Okay. All right. So check out the traces of your exploitation attempts. All right. So what we're going to do here is check that out. I just have to look at this here. So we'll go to this location. And right. CD, and then we'll put little quotations around it. Six. Okay. Dir Tomcat 10.1. Just wanted to see what that looks like. So go CD again. Quotations. Paste that in, and then use the name file Tomcat 10.1, followed by logs, followed by access logs. That didn't seem to work. Okay, so let me try that again. So that would just go to logs. Interesting. Okay, so that's not really working the way I want it to. Let me insert it somewhere else so I can edit it. CD, okay, logs. There we go. Take this, copy, paste it here. Okay, we'll just do it manually, I guess, because it's not wanting to do that. So CD Tom. I still need to use the quotes. 10.1 CD logs ls dir. Those are the logs there, so we're looking for the one for right now. Let's see here. It's going to be one of these access logs. Here's the one for today, but it doesn't have any data, so we want one that has data. Where is it supposed to be at? Should be, these are for the Damien. And then, I don't know what this means, this stdir, but that's a log file with nothing in it. So I guess we'll just look in the ones that have something in it and that are from today. This one's not from today. This one is from today. Let's take a look at that one real quick, see if anything's in there. That's juicy. Okay, so that's when it started. And then one's not from today. Today either. Let's look in here, see if there's anything in it. It doesn't show that there's anything in it. That's interesting. Okay. Oh, never mind. There's stuff in there. And you can see that it has a lot of get JSPs. Very suspicious, very suspicious. And it's got a lot of 404s. Yeah, so I'd say we got attacked. All right, that's complete. Let's go to mitigations. It is essential to check if you have enabled write for the servlets. If the default configuration is kept as is, read-only is not set to false, then you are not affected. If it is set to false, then it is required for your use case to then be set back to true. Okay. You'd want the default configurations enabled write for the servlet. If it's false, then read only is not affected. Read only to be true, so you want it to be read only. The mitigation steps are outlined in this official announcement, and let's see where that goes to. I like to see where the links go to. Is that the official website? Yep, that's the apache.org. There are two main points that the user should consider first. Users should upgrade their installation of Apache Tomcat in particular, and they want to upgrade it to this version here, or this version, or this version. And that's dependent on the whether it's going to be upgraded. That's big. Additional steps are required for users who only upgrade to 11.0.2, 10.1.34, or 9.98. In particular, users of older versions of Java should need to make the relevant explicit changes. On systems using Java 8 or Java 11, the system properties should be changed from the default values and set to false. On systems using Java 17, the system properties should be reverted to false if its default values has been changed. Okay, so need to make those changes. Um, in order to upgrade. Okay. It should be noted that Tomcat 11.0.3, 10.1.35, 9.0.99, and later include checks to ensure that sun.io use canon cache is set appropriately. All right, you want to just check these parameters before you upgrade. If you want to learn more about explain race conditions, we recommend the race condition room. Correct. All right, we completed it and they added like music. I knew they used to have confetti, but the music's new. I think this is really cool because if you want to stay on top of cybersecurity, you've got to be looking at these CVEs. Who knows, you might be doing hack the box or try hack me, and there's a CVE you need to exploit. And if you've done it before and you know about it, then great. Now you know where to start and you know what parameters to change. So that was pretty cool. I liked it. Looking at something like what's that website called? Got the name of it, but there's websites out there can tell you if these public facing servers are running this version of Tomcat. And if they are, then and they have bug bounties, you can ethically report them. All right. So I hope you enjoyed this demo. Hope you have a good day. All right. And by the name, if you noticed, my YouTube channel has changed to Cybersecurity Striker. Hope you have a good one. Danny out.